All right, guys, today we are going to start notes on our next unit talking about alloys. Now, you read a little bit about making different alloys for coins to get us started. Today we're going to talk about what an alloy is. Now, to really get started on what an alloy is, we have to understand the idea of a mixture compared to a compound. If you guys remember going back earlier in this year, we had a lot of information about based in our unit about the difference between the two. A mixture is two or more substances that are not chemically combined. In other words, salt water is a mixture because if you have a cup of salt water that you can compare to another cup of salt water, they may or may not have the same amounts. They're not going to be equal every single time. Okay, they don't have a bond between them. Compared to salt or water on its own, like water is H2O, you're always going to have two hydrogens and one oxygen. It doesn't matter where you're getting your water from. That's how it works, right? So alloys are, as you can guess, a mixture. In other words, they are not chemically combined. It's a material that is made up of at least two different chemical elements. And again, it's a mixture, but more specifically, it is a mixture that includes a metal. So this is why we're doing this right after the metal units. We're going to a little bit more specific about metals now. What is an alloy? Mixture of metal, and it's going to be the main metal. It's going to be the main portion of the mixture. So we call that main metal. It's a majority of the mixture. We also know the main metal as a parent metal or the base metal. So for example, when we're talking about steel, our iron is your main metal. Now, the agent that we put into the iron to make it an alloy is carbon. So carbon in this case would be our alloying agent. That's the material that's there found in smaller quantities, and they can be metals, or like carbon, it can be a non-metal. So main metal would be your base metal, be the majority of the material compared to alloying agents. Now, if you remember when we talked about Damascus steel for the Damascus blades, it had more than one alloying agent. It had the carbon, of course. Those are the majority of the alloying agent, but they also found molybdenum, aluminum. There are several different agents in there, including vanadium. If you remember that vanadium was an alloying agent that actually made a big difference in the strength of the steel, made it a little bit better. So those are your different, two different parts of an alloy. An alloy is a mixture. In other words, it's not going to be the same every time. But the more we learn about it, we can find a little bit more. So here are some other examples of alloys that you may be familiar with. First of all, we have brass. That is copper and zinc. And if we get a chance to come back to school, we will make a brass penny. We're going to use the copper in a penny to turn it into brass. Bronze would be copper and tin. But if you notice on this diagram, you have some other materials that are there, and it's going to give you percentages. So later in this section, we're going to learn how to calculate the percentage of different alloying agents in the material. So like for example, the brass, your copper is going to be, you have to have at least 65% copper in order for the brass to be called brass. Okay, so those are your ratios to each other, your percentages, and that can actually change. And it's not a great science, or not an exact science. We're going to watch a video clip about making a bell later this week, and it's going to talk about how these percentages, you can try to do your best, but it's not going to be the same every time. Other examples, cast iron. You have green gold on there. I'm not sure how many of you have heard of green gold, but white gold is down here. Of course, that is an alloy because gold, we know, has a specific color. White gold would look more a little silver in color. You also have things like rose gold that are out there, that pinkish to it. We have sterling silver. That is adding those other alloying agents to the silver to help keep the silver from tarnishing. There's a lot of jewelry is used to make that. Of course, we have steel. Solder is another example of an alloying, or sorry, an alloy. Pewter, I'm not sure how familiar you guys are with that. but pewter is a metal that was used a lot in the 18th and early 19th century to make things that were common around the household, like candlesticks and cups. I have a pewter cup somewhere. I'll have to find it and bring it in for you guys. But those are some different alloys that you may be familiar with. So, what makes an alloy an alloy? Again, they're not chemically combined. It is a mixture. They do not have a bond to them, which is actually how these things work out. And why this is important is because we think of alloys almost as solid solutions. They occur because those atoms can move through the material. So they're not bonded to each other. So you see a little example of how those materials have moved in and mixed with each other compared to not moving. So you have pure elements over here, and then you have motion between the two over here. And this is what actually happens when we're one way to make an alloy, which we'll talk about in our next set of notes. Okay. So why do we have alloys? Well, usually, very simple, why do we make steel? Why isn't iron just enough for us? Well, we know that steel is actually stronger than just regular iron. It also is harder, so it's less malleable, less ductile, it's less likely to misshape. So there's a lot of different reasons to use different materials. Some examples would be provide durability, making something more conductive, or actually less conductive. If we add certain elements to a metal, it could make it hold up to heat a little bit better. So those are different reasons. Pewter, like I mentioned just a few moments ago, is actually used because it's softer than other ones. So it makes it in the 17th and 18th century, 18th and 19th century, they used pewter because it was easy to shape and mold and quicker to produce those objects that were common around the house. So that's one of the reasons they used it. Not necessarily a great idea, because I remember denting my mom's candlestick one time because it was actually a little too soft. Okay, here are some other examples of common alloys that are used in everyday life. Of course, you're familiar with steel and all the different component or things that can be used with that. I know you know of brass, but I don't know how often you think of what brass can be used for. Of course, you have your brass instruments here, so that's part of it, but different pieces of jewelry in time. Bronze was very common in household products in the 19th century, early 20th century. Still is, honestly. You've got your candlesticks, you've got, of course, the bells, which again we'll talk about that, the bronze medals, that sort of thing. So I'm not sure whether there's the coins from other the Bronze Age, maybe coins, that sort of thing. Okay. But again, different types of alloys, different uses for them. Okay, so what are the actually two main categories of types of alloys? Alloys are created in one of two ways. One would be a substitutional alloy. Now this goes back to, again, our metal crystals and our understanding. These are those it's not the word what's the word I'm looking for? Not defects that were talked about before. We've talked about substitutional alloys. We know that substitutional means that one agent, that alloying agent, is going to replace an atom in the main element. Okay. Examples would be brass, which you see pictured here. Bronze would be another example of a substitutional alloy, and pewter are all examples of substitutional alloy. Now these work, I'm going to go forward here for a second, these work as substitutional because take a look at copper and zinc here, okay, in your brass. These two are your brassing, are what's created in brass, and they're actually right next to each other on the periodic table, which actually means that atoms are about the same size. In order for a substitutional atom to be, in order for the agent to be substitutional, it should actually be about the same size of the atom. Otherwise, it's not going to work. So when we talk about brass, copper, and zinc are near each other on the periodic table, so about the same size. Compared to another good example, which is iron, somewhere here. Whoop. Sorry, I thought I had this going. All right. Well, other examples would be iron and copper, and I had those. There it goes. There's copper. Or sorry, carbon. And iron, if you notice how far apart those two are on the periodic table. Did I just see it, guys? There it is. We can see that carbon is very far away. It's one of the earlier elements. This is element number 6 compared to iron being number 26. It means carbon is actually pretty small compared to iron. That means that carbon, as you know, we've talked about this a lot before, the alloying agent can actually slip between the main metals. So it uses that defect, that interstitial defect, to become an alloy, okay? So if an interstitial alloy is going to work, the atom has to be much smaller. Now there are examples, of course we have steel, but there are examples of some interstitial alloys where it's not much smaller. Of course that's going to make things very hard because it's going to lock those dislocations into place right there. So those are two main types of alloys, substitutional and interstitial, but it doesn't have to be an either or way. So on this diagram you can see here's your pure metal, and the substitutional you have the blue atoms replacing the red atoms in that crystal structure, compared to an interstitial where you have the green atoms in between your red atoms there. But like I said before, you can have a couple different alloying agents. It just depends on what that is. Here's an example of an alloy that is actually both substitutional and interstitial. So it all depends on how that works out. So those are your, what an alloy is, and this is what type of alloy. So we finished the first two parts of the note. We'll come back and work on the others in a little bit. But before we do that, I was going to show you one example of how alloys are made. So if you, whenever you're ready, you can head on to the next lesson.